Hello students, welcome to my channel Agricultural Engineering Online. With continuation of the video lecture series on farm machinery, in this video we will discuss about threshing of crops. Basically, threshing is the operation of detaching the grain from the earhead, cob or pod. Thresher is also a machine to separate grains from the harvested crop and provides clean grain without much loss and damage. So during threshing, grain loss in terms of broken grain, unthreshed grain, blown grain, spilled grain, etc. should be minimum, and Bureau of Indian Standards has given some specification like the grain loss should not be more than 5% and broken grain should not be more than 2%. So most important component of the farm mechanization is the threshing. It is generally done after the harvesting of the crop. If timely the operation is not done, it can waste a lot of crop. Generally, traditional methods of threshing are very slow and give slow output, and due to that the cost of operation is very high. Huge loss of grains also becomes due to rodents, birds, insects, or rain or any other conditions of weather. So coming to the threshing methods, the removal of grains from the plant can be done by striking, tearing or rupturing. Generally 150 to 230 man hour per hectare is required, labor is required, and generally the moisture content at which threshing is done is around 15 to 17%. Tearing the grains or trampling the grains under the feet of the animals or any laborers is also done, or tearing under the tractor tire, striking the grain with sticks, page or loop can be done to thresh the crop. Manually, you can say traditional methods. Also removing the grains by rubbing between the stones or wooden roller on a threshing floor or between the rust bar and a concave, like this. The threshing can be achieved by basically three methods. One is the rubbing action, impact and stripping. These are the three basic methods by which actually the threshing is done. So this is very important for the method by which the threshing is done. Any thresher, actually if you see, this rubbing action or impact or stripping will be there, or combination of all the three might be there. Coming to the optimum moisture content for different operations, harvesting is done at generally 20 to 25% of moisture content, because less moisture content will increase the shattering loss. Threshing is done generally 20 to 25% less than that one for mechanical thresher, otherwise there will be incomplete threshing. Less than 20% for hand threshing. Grain damage is very high if it's less moisture content will be there. Drying generally done at less than 14%. Spoilage and fungal damage and discoloration occurs if it is not done properly at proper moisture content. Storage is done generally less than 14%, generally 8 to 12%. So basically to control the fungal, insect or rat damage. Less than 13% for seed storage, and basically around 8% it is done. Loss of vigor will be there if you dry it further or dry it less. Generally 9%, less than 9% for long-term storage. Milling is generally done at less than 14% but around 12%, so that less grain cracking and breakage will be there if it is done at proper moisture content. Less moisture content, more damage will be there. Coming to the moisture content calculations, if let us see the moisture content initially of a certain grain is MCI on weight basis, initial weight is MI, and final moisture content after drying, let it MCF is the moisture content, and final weight is MF, the total weight. Then we can find out the moisture content on weight basis will be equal to MI minus MF divided by MI. In this case, MI is the total weight and MF is the final dry weight. So this is dry weight, this is MI is the initial weight. So this is the MI minus MF will be equal to the moisture, actually amount of moisture you can say. And if you want to find out the in dry basis, the MF will be at the denominator. So MI minus MF divided MF into 100. From moisture content dry basis to wet basis you can calculate by this formula. Generally it is under the drying Here actually only the formula is given to find out how many moisture content is removed during the drying process. So weight loss during drying will be equal to mf, which is the final weight, is equal to mi into 100 minus mci divided by 100 minus fcf. Coming to the threshing operation, so there are process of operation like this: feed the harvest crop to the threshing cylinder, thresh the grain out of the ear head, separate the grain from the straw, clean the grain. So basically these are the main operation during the threshing. After the threshing, generally the straw or bhusa is made for the suitability of the feeding of the animals. Coming to the different types of thresher, according to the crop being threshed, it can be classified as single crop thresher or multi-crop thresher. For different crops it can be used at the same time. According to the functional component, the threshers can be classified as drummy type, where there will be drums on which there will be threshing units will be there, or regular type, where it is called as throughput type of threshers, where actually the feed or the crops are fed into a feeding tube. And axial flow, where actually you can say the axially the crop moves inside the cylinder, so that it is called the axial flow type thresher according to the functional components. Or it can be classified as according to the types of threshing cylinder: syndicator type, where the crop is cut into pieces so that it can be easily threshed. Less actually in this case the cylinder consists of a flywheel with corrugation on the periphery and sides, which rotates inside a closed easing casing. And concave, the rims of the flywheel are fitted with chopping blades, so that chopping actually takes place between the of the crop. And or hammer mill type or beater type, where actually it is actually the it is similar to drummy type, but it's provided with aspirator type blower and sieve shaker, so that cleaning will be easier. This hammer type you can see here. So next is the spike tooth type. So where actually spikes are mounted on the periphery of a cylinder that rotates inside a closed casing. And concave, so basically it is provided with cleaning sieves and aspirator type blower. Next, coming to the rasp bar type thresher, where actually you can say corrugated bars are mounted axially on the periphery of the cylinder. It is fitted with an upper casing and an open type of concave at the bottom of the cylinder, like this. Next, coming to the principles of threshing. First up, it consists mainly of revolving cylinder and the concave. Feeder beater is there to assist the elevator feeder in feeding the grain to the threshing mechanism, just like it consists of a cylinder and a concave. So like this, a concave, the crop is feed here, and if there is certain feed beaters are there to feed it easily, so this is called the star wheel type feeder. Most threshers are provided with a rasp bar type cylinder and concaves. The grains is robbed from the stem without materially cutting the straw. Generally the straw is not cut, but the grains are robbed from the stem. Tooth type cylinders and concaves are available in some combines. Adjustment are generally provided for varying the speed of the cylinder to suit the kind of crop being harvested. Generally the drum should revolve at a particular speed for a particular crop, otherwise it will have lot of grain damage. Coming to the straw thrown into separating mechanism and grains fall through the concaves, like here actually the grains are falling over the concave, and it is just grain carrier will be there and it is collected here. Next, coming to the functional component in as a whole, you can say here the components are like, first of all, feeding unit, where actually the crop is fed. You can see here threshing unit, where actually the crop is threshed inside inside this there will be concave and cylinder. Cleaning unit, where actually the crop is grain is cleaned from the bhusa or chaff. Coming to the cleaning unit, it consists of aspirator blower and reciprocating sieve. Aspirator blower generally blows away the chaff and straws from the grain. Clean grain is actually sieved through the reciprocating sieve and it's collected at the grain outlet. Coming to the power transmission unit, so power is transmitted from the engine or power source to the axis of the threshing cylinder as well as the aspirator blower, and it also gives the power to the reciprocating sieves. Main frame actually is fixed and it fixes all the parts together, and it also has transport unit where actually transport wheels are provided to transport the thresher, because it's a very big one, to the point where actually threshing will be done. Coming to the feeding type of thresher, one is hold on type where actually the crop is held on the threshing cylinder so that it is threshed, and in throw in type the crops are fed into the cylinder through the feeding chute. Like this, here you can see the feeding chute is either platform type or hopper type. Hopper type also feed is feed, or in feeding chute type it is feed on the platform. And also the casing and cylinder has some small gap, so when it moves actually it is moving like this. And if the crop is clogging type, so there is a small star wheel feeder is there to push through the feed into the threshing cylinder for the threshing. The threshing also is done by different type of feeding type. It is radial flow. Actually the flow of the crop in the cylinder is radially, and it can be also axial type flow. Here actually the crop passes through more length during the threshing so that the threshing is more efficient in the case of axial flow. Coming to the threshing unit is mainly consisting of cylinder and concave. Different type of threshing cylinders are spike tooth or peg type, where the spikes or pegs are arranged on the periphery of the cylinder. And if coming to the rasp bar, their rasp bars are there which are actually distributed over the periphery of the cylinder, and angled bar can be also used for the threshing unit. So there will be, instead of rasp bars, there will be angled bars. Wire loops are also used to in a straight manner or zigzag manner on the periphery of the threshing cylinder, so it can help threshing. Syndicator or hammer mill type, where actually the crop is cut into pieces, so there will be some beater type will be there, or cutting type units will be there inside the threshing unit. Coming to the cylinder concave, basically the cylinder between the cylinder and concave there is some clearance, so that is called the concave clearance. So concave clearance is very important for the different type of crops. So if you see for the wheat and paddy, basically the two main crops, the clearance is different for different crops. If you check, let us this is the cylinder and this is the concave. So basically the gap between the cylinder and concave is called the concave clearance. So for wheat actually the clearance is around 5 to 13 mm, and for paddy it is generally 5 to 10 mm. So if you see the gap at the inlet is more than the outlet, so that the crop is squeezed inside the crop between the cylinder and the concave, so that the rubbing and other actions will be happening, so that the crop straw will come here and the grains are falling through the concave. Basically the concave clearance, if you reduce, if concave clearance is reduced, then what happens? So there will be more squeezing, more pressure on the crop, and there will be more efficiency of threshing, so that more grains will be separated from the crop. But at the same time there will be clogging on the between the cylinder and the concave, and also it will help loss. So there will be two things, one is the efficiency of threshing, and another is the loss. So if the efficiency of threshing increases, loss will also increase. So therefore the reduction of the concave clearance. So concave clearance is less, then efficiency of threshing will be more, and loss will be also more. So basically there are two type of screens are given on the concave. One is called the screen type concave. This is screen type. So here actually if you see, It is made of MS steel generally, MS steel, and this semicircular shape like this, and there are a number of bars like this. So they are arranged in such a way that they will make a screen. So screens will be there. So they are also made of wires also sometimes, or bars, so MS bars. So when it moves, the crop moves through the concave, then the grain will fall here actually. This is screen type cylinder concave. Also there is perforated type, you can say perforated. So perforated type concave, where actually the concave is made of a flat sheet, you can see like this. So here actually there will be perforation on the flat sheet, and it is closed from the both end into the sheet, so that the size of the perforation is made according to the size of the grain, so that the grains falls through the concave. So there are two types of screen, concave screen type or perforated type concave. Next, coming to the paddy thresher. So paddy is threshed by manual thresher or pedal operated thresher, or it is done by a little sophisticated or more safety type thresher, where actually in this case it's open, it's closed one, so that there will be the crops cannot be come to the operator's eye, or there will be little this platform is there. It platforms helps to that hand or any other organs do not come into the contact of the thresher or cylinder, so that less damage. So this is good one. And here actually if you see there is also blower is here, so you can say it is a power thresher and it is a pedal operated thresher. Pedal operated thresher. Coming to the automatic thresher, here where actually there will be feeding chute directly, and there will be a platform to keep this, and everything will be done here. And this is just the advanced version of this power thresher. So here actually you can say automatic thresher. Coming to the multi-crop thresher, actually number of crops, different crops can be threshed by a single thresher, that is called the multi-crop thresher. Here actually there will be adjustments for adjustment will be there. One is for the speed of the thresher, that is cylinder, then the concave clearance. Concave clearance, these are the two most important one. Others are like the blower speed and other things can be adjusted, so that it can be used for different crops, because different crops need different concave clearance and also different beating speed to the crop. Next, coming to the threshing of grain. First of all, the thresh of total grain input to the thresher will be let it gross yield from the crop field. The field is having certain area, and so that some maximum yield will be there, that is called the gross yield, which can be a possible one. This when this grain or yield is fed basically with the crop, this is basically with straw. So total crop is fed, so that the total grain will be the gross yield. Then that can be after threshing. There are two parts. One is the grain at the main outlet and grain at other outlets. So the grain at main outlet will be called as net yield, and the other outlets they will be called the grain loss. Generally the grain loss is done at sieve, sow, rake, feed, free grain of the rake, and other things will be called as loss. So loss and yield, net yield. Net yield can be again classified into unthreshed grain and threshed grain. So threshed grain again on the threshed grain might be in the case of loss grain. So loss grain also can be classified as unthreshed grain and threshed grain. So basically the threshed grain will be there in the loss, or unthreshed grain will be there on the loss. Similar things again, the threshed grain in the main outlet will be classified as, or they can be again classified into clean grain, and another is the broken grain. So basically the clean unthreshed grain can be recirculated into the first case actually, so that it again threshed. So this is basically, this is not threshed. Again some unthreshed grain is there in the losses also, that can be also fed into here actually, but it's very difficult from the losses, but from this it can be separated in the from the clean grain outlet. And also coming to the broken grains. So basically the during the process of threshing, some grains are broken into pieces. So coming to the threshing efficiency, let us see how much efficiently the threshing cylinder actually separates the grain from the crop. So let us see, this is the grain, total grain input. Let us see, this is the gross yield at the input to the threshing cylinder, and at the grain main outlet, this is the net yield. Here is net yield and this is gross yield. So gross yield and net yield, the threshing efficiency will be equal to gross yield minus unthreshed grains. Total unthreshed grain minus unthreshed grain will be two parts. One is at the loss and another is at the main grain outlet. So total unthreshed grain, if you separate, then total clean grain, or that is threshed grain divided by gross yield, will be equal to threshing efficiency. Coming to the cleaning efficiency, how much efficiently the clean grain is getting from in the main grain outlet, that means minus broken grain. So all the threshed grain at the grain main outlet minus broken grain divided net yield, or the total grain at the main outlet into 100 will be cleaning efficiency. Coming to the percentage broken grains, there is the broken grain at the main outlet divided by net yield, or total grain at the main outlet, that is percentage broken grain. And coming to the percentage blown grain, is how much percentage of grain is blown away by the Bhusa outlet, or here actually if you see how much is actually blown away by the blower to the Bhusa outlet, that is divided by total yield or net yield at the main grain outlet, that is percentage blown grain. And coming to the percentage spilled grain, there is whatever the total losses at the sieve, sow, rake, or any free grain over the rake, that is divided by total grain at the grain main outlet, that is equal to percentage spilled grain anywhere. So there is, these are the different efficiencies of the thresher. This is actually calculated on the basis of the gross yield, or the main total grain input to the thresher. Coming to the throughput capacity, so throughput capacity is the nothing but the it can be defined as the total amount of material fed to the total amount of material that is fed into the thresher. So that is called the, in kg per hour, this is called the throughput capacity. So how to calculate throughput capacity? So first of all, you need to know the grain to store ratio. So grain to store ratio, so nothing but you can calculate the amount of grain. So you can say amount of grain in kg produced from threshed grain for 1 kg of grainless straw produced after threshing actually. This is called the grain to store ratio. Generally for a particular crop, grain to store ratio is maintained. So this depends on the total yield or yield in the actually crop. So it depends upon depending on the crop. Generally the ratio is varying from 1.25 to 1.5:1. So if you say this is the grain to store ratio, then it can be defined is like this. So in this case, if you know the grain to store ratio, you can calculate the throughput capacity. How to calculate throughput capacity? The throughput capacity, let it see in kg per hour, that will be equal to gross grain input. If you know in kg per hour into 1 plus grain to store ratio divided by grain to store ratio. So that means, for example, let's see 1.5:1. That means in 2.5 kg, each 2.5 kg contains 1.5 kg of grain and 1 kg of straw. Therefore, so 1.5 kg of grain is equivalent to 2.5 kg of throughput capacity. That means, therefore 1.5 into 2.5 divided by 1.5, that will be equal to 2.5. So total 2.5 contains 1.5 kg of crop. 1.5 kg of grain. So therefore gross grain input you can also calculate, that is gross grain input. If we know the throughput capacity, that will be equal to, at this is also kg per hour, that will be equal to, that is clean grain at main grain outlet, that is kg per hour plus all the grains at all outlets, you can see. So the total grain is the gross grain input, and if you know the gross grain input, then you can find out the throughput capacity. So throughput capacity is the total amount per material. So I think you understand everything. So please like and subscribe to my channel.